Okay, welcome to this first introductory video on running Spark locally on your own computer and some of the things that you can do with Spark should you choose to do so. I'd like to start this video not by going through code first, but just reminding you a little bit about the architecture of all of these pieces of software that we're really trying to put together here. And then after we do that, we'll jump into running through some code that will take a look at running Spark on your local computer using the sparklyr set of packages. So you might remember from last time that there are a bunch of layers that you can think about when you think about this kind of distributed computing infrastructure that we've talked about and that you can build up. So at the bottom, we've talked about distributed file systems. So for example, the Hadoop file system, which is really a file system that's distributed over maybe many nodes in a network. So we have maybe many machines, all of which are pooled together to create this file system, distributed file system for storing really large files and making those files available to many nodes that might be wanting to do computation. Then you saw that on top of that, you might build a computation layer, so something like MapReduce with Hadoop, earlier versions of Hadoop, or more recently Yarn. So these are pieces of software that coordinate your computational nodes, figure out how to distribute the tasks among the nodes, and then collect the results, etc. So those also will take advantage of many different computational nodes, maybe the same, maybe different. More recently, Spark is another distributed computing system that can sit either on its own without the help of those other layers, or can sit on top of those other layers and use them as part of its distributed computing framework. So Spark itself contains code to break problems and data into pieces that are stored in memory and on which you can do analysis. It's pretty fast because it does store the data in memory. On the other hand, solutions like Yarn and MapReduce rely more on storing data on disk, and those both have pluses and minuses, but Spark can work on its own, or it can leverage what's provided by Yarn and Hadoop file system and all of that underneath it. Then to work with Spark, there are lots of interfaces. So we'll be talking about interfaces between R and Spark because that's been the computing system we've been building up in these classes. But it's also possible to run Spark through Python interfaces, or even Java or Scala, for example. So all of these languages can provide an interface into Spark to get it to start doing things. And in most cases, the goal in those higher level languages is to provide functions and interfaces that conform to what you as a user would be used to in those environments, but that behind the scenes create the more low level code that Spark is actually going to run. So in the first part of these lectures, we'll be concentrating on this top part. In particular, if we've got Spark installed locally without maybe any of these lower layers, but just Spark on its own and an interface to R, what can we do? And then in the second part of the module, we'll at least take a little bit of a look at combining Spark with a cluster of computers and using the distributed file system to help with larger data files. Okay, so most of this lecture will be walking through some code. I won't read everything that's in the code, but I hope there's enough annotation that you can read it if you come back later. So I'll hit the high points and talk about what the code does, and then of course you'll be able to come back and try it on your own and also read it. So to run this code, the first thing we need to do is to install packages that we might need, including sparklyr, which will serve as our interface into Spark. So I've got this code commented out because I don't want you running the code over and over again and reinstalling the package every time you do. So my preference is to comment out the installation commands and then copy them. And then if I have to install, I paste it in the console and run the commands from there. There are other ways to do that, but that's what I like to do. So you'll need to install sparklyr. I've done that already. And once you've got that installed and you run the library, the sparklyr library, I guess would be step 2, a command within sparklyr is the command spark install. And if you run the spark install command, that will download and make available a version of the Spark code that you can run locally from R. You don't need a cluster. It'll run on your own computer. It has a chance of doing some things faster because by default it will try to run Spark using all of the cores of your computer, and if you've got any sort of modern computer, you've got multiple cores inside your computer. So it will try to use them all to run basically a simulated version of a Spark cluster, and that could end up giving you faster code because by default R will run on a single core rather than multiple cores. We'll see that that doesn't always happen, but even on a local computer, for certain tasks, you might find some savings in running Spark like this. You can run the spark install command without any options, and it will download a default version of Spark and get it ready for you. But I've found that on my computer at least, I'm running a new enough version of Java, Java 11 on my computer, that I need a newer version of Spark than what Spark install defaults to. So I have the version set to 3.1 so that it'll play nicely with my version of Java. It'll take a little while to run those installation commands. I didn't have any problem with them giving errors or anything once I got the right version set, so hopefully that'll be the case for you as well. And then once you've got those installed, we can run some libraries and get started with actually running some code. So I've got tidyverse here, I've got sparklyr, and the other package that you might have to install is the New York City flights from 2013, which is a standard data set. And we'll be using that at least for the examples in this first part of the module. So we'll run this and get it loaded in. Get our standard messages here. Okay, now in order to get Spark working, there's a series of things that you have to do, and we'll kind of work through those one at a time.